All right, on our big derivatives practice, we have 30 problems. We're going to have a mastery quiz on it next class. You want to be pretty good at this. The first thing is to identify what type of rules you'll need to be using. This first one, I'll do a few examples. This first one, we have 2 times something. So this is a constant multiplier. So it's going to be 2 times whatever the derivative is. I should label the derivative as f prime of x equals. So when you have a constant multiplier, it'll still be there, times the derivative of whatever this thing is. So the derivative of e to the 4x, well, we know that what the derivative of e to the x is. E to the x is e to the x, but this is e to the something. So this is a chain rule. The derivative of e to the something is e to the something times the derivative of that something. The derivative of 4x is just 4, and so this is equal to 8 e to the 4x. All right. Let's look at the second one. We have sine of x times e to the x. Notice that e to the x is not inside of sine, it's being multiplied. It's sine of x times e to the x. So we don't actually have a chain rule thing going on here, we have a product rule. And the product rule says that we do the derivative of the first times the second, left alone, plus we leave the first one alone, times the derivative of the second one, and the derivative of e to the x is still e to the x, and that's it. We can leave our answer like this. This is completely fine. We could also, they both have an e to the x in them, and so if we wanted to, we could factor out the e to the x, but there's no reason to do this. Both of these answers are completely correct. One is not better than the other. All right, let's look at this next one. Here it's g of t, so this time the variable we're going to be taking the derivative of is with respect to t. So we're going to be doing g prime of t equals, okay, cosine of e to the t. Unlike this last one where it was sine of x times e to the x, this is cosine of e to the t. This is inside of the cosine. It wouldn't make sense to think of it as cosine times e to the t because you can't have cosine without something inside of it. So the thing that's inside of it is e to the t. So plus t. So we have this plus. The way we do a sum or a difference is we do the derivative of the first one plus the derivative of the second one. So we'll just do these separately. This first one is a chain rule. So we do the derivative of the outside function, so negative cosine, negative sine with the inside still inside of it, negative sine of e to the t, times the derivative of the inside, which is e to the t. So that's our chain rule. I guess I should write the rule for what maybe you missed today or something, you completely forgot it. If we have a function h of x equals g of f of x, then h prime, if you have a function inside of another function, the derivative is the derivative of the outside function with the inside function still inside of it, like normal, times the derivative of the inside function. And that's what we did here. We did the derivative of the outside function, but with the function that was inside of it still there, times the derivative of the inside function. All right, now we have to do this plus t. The derivative of t is just 1. And so that is our derivative. All right, let's see. I think some of you might have trouble with number 6, so I'll do that one. F prime of x equals, we have tangent of something. And so this is a chain rule. The derivative of the outside function, the derivative of tangent you need to have memorized is secant squared with the inside function still inside of it, times we need to do the derivative of the square root of x. Some of you may know it by now. It comes up often enough it's worth knowing. But if you don't know it, square root of x is x to the 1/2 power. And so when we do the derivative, it's 1/2 x to the negative 1/2 power. It's just the power rule. We lower the power by 1 and multiply by the power. And x to the negative 1/2 is 1 divided by square root of x. So it's 1/2 times 1 divided by square root of x. The negative power means you divide. The 1/2 is a root. And so we have times 1 over 2 square root of x. If we want, we could rewrite this. We could multiply times the 1 because we could always put something over 1. So we could say secant squared of square root of x divided by 2 square root of x. Notice that the square roots do not cancel because this is inside of secant. It's not multiplying times secant, it's inside of it. Let's see, other ones you might have some trouble on. Let's do number 12. I think it's a good one. Here we have something getting taken to a power. And so this is a chain rule. There's a function to the negative 2 power. And we know if it was just x to the negative 2 power, what we would do is we would multiply by the power and lower the power by 1. And that's what we're going to do here. It's going to be negative 2 times that same thing to the negative 3rd power, right? Times the derivative of the inside function. So we take the derivative of the outside function with the derivative of the inside still in it, times the derivative of that inside function, which is 6x squared. We can simplify this. Oh man, this is bad labeling here. I made it look like g of x is equal to this, but that's not true. This is now the derivative. So g prime of x equals this. And now I can put equals because it'll just say the derivative is equal to this. Negative 12x squared, and then this is a negative exponent, so it's divided by 2x cubed plus 4 cubed. Okay. Let's see. Ooh, let's do this one. This one's fun. Here we have natural log of x plus 2 times e to the x to the 5th. And so these are two things getting multiplied times each other. So we're going to have to do the product rule. Now we might also notice there's something inside of this e to the power of something. So we'll end up having to use the chain rule too. But first, this is two things times each other. F of x times g of x. So we need to start with the product rule. H prime of x is equal to the derivative of the first one. We have a chain rule going on here too. The derivative of the first is the derivative natural log of something is 1 over that something times the derivative of the inside. The derivative of x plus 2 is just 1. And I'm not even going to write it because multiplying by 1 doesn't do anything. Whenever you have x plus something or x minus something inside of a function, it'll always be, the chain rule will be multiplying by 1 and you don't need to write it. Okay, so it's, here's the derivative of the first one, times, we leave the second one alone, plus, this is the product rule, derivative of the first times the second, plus, leave the first one alone, times the derivative of the second. Now when we do the derivative of this, this is going to be a chain rule. It's e to the something. The derivative of e to the something is e to that something times the derivative of the inside, which is 5x to the 4th. We usually move this to the front, and we can put this on top. So this is e to the x to the 5th divided by x plus 2 plus 5x to the 4th, natural log of x plus 2, e to the x to the 5th. And that is our ugly answer. You know, the 14 is interesting because we could multiply out first and then do the derivative, or we could use the product rule. Either way, it would come out right. 15, obviously, you'll need to do both the quotient rule and when you do the derivative. I'll do this one. Let's just do this one. So earlier when it was y, I wrote y prime. This time I'm going to write it a different way just so we're used to it. dy dx equals, so the derivative is equal to, this is the quotient rule, so we're going to have to do the derivative of the top times the bottom. So the derivative of the top, we have a constant multiple, so it's still going to be there, times cotangent. The derivative of cotangent is negative cosecant squared, so we're going to put the negative in the front, and then cosecant squared. So it's the derivative of the top times the bottom minus, we leave the top alone, times the derivative of the bottom. Now the derivative of the bottom, it's not just sine of x, it's sine of something. There's an inside function. We're going to have to use the chain rule here. So it's times, the derivative of sine is cosine, so cosine of 4x. So it's the derivative of sine with the inside function still inside of it, times the derivative of 4x, which is 4. All divided by the bottom squared. We write that as sine squared of 4x, although you could have put sine of 4x in parentheses squared. We do simplify this just a little bit. We can multiply the 3 times the 4. And, ooh, we can actually do, no, okay, we can't simplify more than that. I thought there was going to be some neat trig simplifications we could do, but because the arguments, the thing inside of the trig functions aren't the same, we can't simplify there. But if they were the same number inside, we would be able to simplify quite a lot. And that would have been fun. Okay, great. Let's see. Fun ones on the back. I really like number 18 here. Number 18 is nice because it looks like it's a quotient rule, and it is. You could do this as a quotient rule, or you could simplify first, and that makes it a ton easier because, remember, this could be, there are two ways to think about it. X squared is dividing into both of these, and it distributes, right? Like dividing distributes, so we could rewrite y. Notice this is not y prime, this is still y. 2x cubed divided by x squared is just 2x. 4x squared divided by x squared is just 4, and so that's what y is. So the derivative is 2, and we're done. You could also think of this as 2x cubed plus 4x squared times x to the negative second power, and distribute the multiplying. When you multiply, you add the exponents, and so you get 2x plus x to the 0th power is 1. And so, you know, we get that same thing. That's another way to think about it. Or you could have just done the quotient rule, and it would have been a lot of work to get a very simple answer. All right, let's see. I want to do this row because I think it's interesting. Sine of x. Notice sine of x is inside of sine. So this is a chain rule. The derivative of the outside function, cosine, with the inside function still inside of it, times the derivative of the inside function. The parentheses are kind of important here to show where things end. Notice the difference between that and this one. Here it's sine of x times sine of x. These are multiplying. This is a product rule. It's the derivative of the first one, leave the second one alone, plus leave the first one alone times the derivative of the second one. And then these are the same things, so we can combine them. 2 cosine of x, sine of x. You know, we could have done this using the chain rule if we had rewritten this at the very beginning. We could, sine of x times sine of x, another way to write this is sine squared of x. And now this is a chain rule thing. It's something being squared. And the derivative of x squared, something being squared, is 2 times that something. So 2 times sine of x times the derivative of sine of x, which is cosine of x. And that gets us the same answer. 24 is fun because it's sine of e to the 5th. And so you can start doing this big chain rule thing, or you can just recognize that e is a number. It's a constant. E to the 5th is also a constant. Sine of a number is a number. Sine of that number is a number. All of this is just a number. It is some number. In fact, let's just do it on a calculator. I want to know what sine of e to the 5th. Oh man, I'm on the wrong screen. Sine of e to the 5th. It's going to be some number. It's actually equal to negative 0.63. And the derivative of a constant is equal to 0. We don't need to do any work. We just need to recognize this is a constant and the derivative is 0. Or you could have done this big long chain rule thing. You could have said, you know what? Okay, the derivative of the outside function is cosine with the inside function still inside of it times the derivative of the inside function, another chain rule, is cosine of e to the 5th with the derivative times the derivative of the inside. The derivative of e to the 5th is e to the something times the derivative of that something. Well, the derivative of 5 is 0, and all of this stuff multiplied by 0 gives you 0. But that's way more work. Okay. Okay, I'll do one more. This is probably the last one I have time for. It's e to the something, and that something is a product rule. But this is, well, we have to notice the main thing is it's e to the something. It's a chain rule. So the derivative is e, the derivative of e to the something is still e to that something. And then times the derivative of the inside part. I need to do a product rule now because this is a product. So the derivative of these two things multiplying is a product rule. The derivative of the first one is negative 3 times the second plus, leave the first one alone, times the derivative of the second. The derivative of natural log of something is, we divide by it, and here we have to do a chain rule thing. The